Okay, in this last section, which is 1-5, day 1, we are going to talk about the last topic in calculus. We've done derivative as rate of change with the 3-point table. We've done integral with counting squares and trapezoids. Now we're going to talk about the big idea of limits and the very informal, easy to understand definition of limits. So we'll go with the informal definition of limit. And what it says is, as you approach a given x value, but the idea is that you never actually reach that x value. So, not ever equal to x. So you're approaching x, but you don't ever land on x. So as you approach a given x value from the left and the right, does the function approach a single y value? If you say yes, it approaches a single y value, that y value is the limit of the function. So the y value is the limit. So when you've got a problem that's asking for a limit, think I'm only looking for a y value. So let's take a look at some examples on graphs, how you can see if a function has a limit and tell what it is. Let's go just rough sketches, somewhat rough. 1, 2, 3, 4. 1, 2, 3, 4. Let's put a hole in the graph at 1, 2. And then the function continues up. Then we'll have it hit at 2, 3. And the first question I'm going to ask is, does this have a limit as x approaches 1 of function f of x? So that's saying, what's the limit, if it exists, as x approaches 1 of function f of x? So like I said, we're looking for a limit, you're looking for a y value. The best way to tell is I am going to approach 1 and use 2 fingers. Here I'm back in the negative x values, here I'm at about past x is 1. I'm going to approach the 1. Do my fingers approach a single y value? In other words, are they going to touch each other if I was to get to 1? And what is that y value at that point if I actually got there? Well, it's 2. So the limit here is 2, because if I could touch the 1, that's what the y value would be. So as I'm getting closer and closer and closer to the 1, I'm getting closer and closer and closer to 2. So the limit here is 2. Another. One, 2, 3, 4. Let's put an open circle at 1, 3. Filled in circle at 1, 4. And then we'll have this graph scoop through here. Didn't show you any of that, I don't think. So that was 1 to 4, open circle at 1, 3, filled in at 4. And now my question is there a limit as x approaches 1 of f of x? Well, it's the two-fingered approach. You want to slide your fingers closer and closer to the x value of 1. Do they approach a single y value? Remember, I never actually reach 1. Are these two fingers getting closer and closer to the same y value? I don't care that that point's up there because I'm not running my finger along that point. I'm on this curve here, and they are getting closer and closer to 3. So the limit is 3. That point's there to confuse you. Okay, make sure I'm on the screen this time. Okay, we have a nice piecewise function. Two. 1, 2, 3. Put a 1. Open circle there at 1, negative, or negative 1, negative 3. Is there a limit? Oops, limit. Limit as x approaches negative 1 of f of x. Use your two fingers. You're going to approach negative 1 from the left and the right. So you're just sliding along the graph, along the curve. Are these two fingers ever going to touch each other and be at the same y value? Not a chance. This one's approaching 2. This one's approaching negative 3. So there is no limit. Let's try one more. Make sure you got it. Squeeze it in over here. So 1, 2, 3. 1, 2, 3. Let's hit 1, negative 3. 2, negative 1, 3, 0, nice continuous function. So is there a limit as x approaches 1 of f of x? Okay, here's the x value of 1. So I'm going to slide my fingers together until I approach 1. And what y value am I getting closer and closer to? As long as your fingers are coming together, you are getting closer and closer to something. And it's negative 3. The limit as x approaches 2 of f of x. Think, what y value am I approaching, if any? Here. My fingers will touch. If I get there, I'm getting closer and closer to the negative 1. And then the last one, the limit as x approaches 3 of f of x. And here, what's that y value I'm getting closer and closer to? That'd be 0. So that's our basic intuitive approach. When you think limit, think y value. If you have a graph, you can kind of see it on the graph. Now we're going to develop the formal definition of limit. I need another piece of paper. Okay. So we want to develop the formal definition of limit. And we're going to do it in steps. So I would like you to graph f of x equals 0.4x squared minus 10 divided by x minus 5. So, I gotta go grab a calculator. Alright, so we got y equals, clear out what you have there. Remember, you're going to need parentheses around the numerator and the denominator. So 0.4x squared minus 10 divided by x minus 5. Zoom 6. Okay, looks like a nice linear function, but take a look. Remember, what's the one number we cannot divide by in our world? We can't divide by 0. So, is there an x value that makes this denominator come out 0? Sure is, at 5. But if you look at 5, 1, 2, 3, 4, 5, it looks like it's just fine. Nice solid lines through there. But you have to know from algebra that it is not. There's a hole in that graph. Anytime you've got a denominator that equals 0, you've got one of two things happening. There's either a hole in the graph, or there's an asymptote that the graph keeps getting closer to. So because this looks continuous, you know it's a hole in the graph. And we're going to be able to remove that hole in the graph. So, when we graph this, when x is 5, 1, 2, 3, 4, 5, it would be nice to know where that hole is at. So if you go into the table set, have it go to 5, we should see an error there. See the table? There's an error at 5, and if I look, as I approach 5 from the left, the smaller side, 3.8, 3.92, 3.96, there's the hole in the graph. After the 5, I'm at 4.04, 4.08. It looks like I was approaching 4. So the hole in the graph is at 4. So 5, 4 is where that hole is, and then it's linear. Alright. If you take a look at just substituting 5 in there, now we already know what's coming out with the 0 in the bottom. Let's see what happens in the top. So f of 5, if you do it algebraically, plug and chug, got 0.4x squared, well that's 5. 5 squared minus 10 over 5 minus 5. So 5 squared is 25. 25 times 0.4 is 10. 10 minus 10 is 0. Anytime you get this 0 over 0, that's called the indeterminate form. Means the answer can't be determined. But whenever we get that hole in the graph, that's called a removable discontinuity. We can remove it by factoring. So we're going to remove the hole by factoring. So here's what we've got.